Hi guys, today we are going through lesson 8.6, solving quadratics by factoring, day 2. Your learning target is I can find the solution of a quadratic equation by factoring. So we're just going to go ahead and jump right in. Really, this is just factoring review, specifically for greatest common factors and for slip and slide method. So we just have to recall what we did in our previous chapter and then take it one step further to solve. Example 1 is actually going to start out as a greatest common factor problem. So on all of these, just like when we were just factoring, we need to check for a greatest common factor. So I can actually take out a 3 from all of these. So I'll have 3 on the outside, x squared plus 3x minus 4 is equal to 0. And then I go ahead and find factors of 4 that subtract to positive 3. And those factors are 1 and 4, with 1 being negative. So I'll go ahead and write these out. 3 on the outside, x minus 1, x plus 4 equals 0. Last chapter, we would have stopped here. We would have been factored. We need to solve now, though. So I go ahead and I split each of these up anywhere where there's multiplication. I get here that 3 does not equal 0, so this doesn't really do anything for us. I have x minus 1 equals 0, and I have x plus 4 equals 0. So on each of these, I just go ahead and solve. So I get x equals 1, and x equals negative 4. So just like our previous lesson, we need to make sure we put these in curvy brackets because they are not a coordinate and they are not a vertical line. They are points on our x-axis. So recall really quick, when I graph this, it's just going to be a really quick sketch, but I have points of my parabola in these two locations. And then it would be something like this. It's not exact, but I have a 1 and a negative 4 where my graph crosses the x-axis. Example 2, once again, is another greatest common factor problem. I can divide all of these by 5. So I'm going to do that. 5 on the outside, x squared minus 4x minus 12 equals 0. Then I find factors of 12 that subtract to 4. This is 6 and 2, with 6 being negative. So I have 5 on the outside, and then x minus 6, x plus 2 equals 0. Go ahead and split these down the middle wherever there is multiplication. Once again, 5 does not equal 0, so this doesn't help us any. But I can solve for the rest of these x values. And we do have that shortcut where you can just switch the signs and get your solution. So in the end, x is equal to negative 2 and 6. So once again, if we were to graph that, my x-axis points would be at negative 2 and positive 6. So that is greatest common factor, and then a normal trinomial problem. The next two examples have no greatest common factors, and we actually just have to slip and slide. So let's jump right in and review our slip and slide. Remember, you have to slip the a value back. So we are left with x squared plus 3x, and then you multiply that a value times the c value, negative 10. You find factors of 10 now. That will get us to 3. So it is 5 and 2, with the 2 being negative because 5 times negative 2 is negative 10. And 5 minus 2 is 3. So we have x plus 5, x minus 2. This is a slip and slide, so I have to slip this 2 back under. Reduce if I can. In this first fraction, I cannot, so I have 2x plus 5. The second fraction, I can, so I have x minus 1, and these both equal 0. Last chapter, we would have stopped here. This chapter, we do need to take it a step further, where we set each of these factors equal to 0, and then solve. Sorry, it's kind of teeny down here. I end up with x equals negative 5 over 2. And x equals 1. So my solutions and my curvy brackets are these two things. Example 4 is also a slip and slide problem. There is no greatest common factor, so I'm going to go ahead and slip the 8 back and multiply. So we have x squared minus 22x plus 40 equals 0. And then I go ahead and I find factors of 40 that will combine to 22, negative 22 to be exact. If I have 20 and 2 and I make them both negatives, these will get me, when multiplied, to positive 40, and when combined, to negative 22. So these are my two factors, x minus 20 and x minus 2. This is a slip and slide, so I need to slide 8 under each of these. These can be reduced. This first fraction, 20 over 8, can both be divided by 4, so we have 5 over 2. And the next fraction can both be reduced by 2. We have 1 over 4. Since these both still have denominators, we need to move those back up to get our factors here. So we have 2x minus 5 and 4x minus 1. Since we are solving, we cannot stop there. We have to set these both equal to 0. So we divide our space here. I think I'm going to run out of room again. We have 2x minus 5 equals 0. 4x minus 1 equals 0. Solve for x. Let's see if I zoom in if it's better. So x will equal 5 over 2. And when we solve the other one, x will equal 1 over 4. So our two solutions in our curvy brackets and when graphed are 5 over 2 and 1 over 4. Okay, so you'll notice the next 4 problems maybe you've seen, I already have stuff written down. I would like you to pause the video and try to work through 1, 2, 3, and 4 on your own. You say you try off to the side, you should be able to do them. 1 and 2 are greatest common factors, and then normal factoring, and 3 and 4 are problems that you have to use slip and slide. So make sure you can do it. Pause me. And then once you've tried, unpause and look at the solutions. Okay, hopefully you pause the video and you can now take a second to look through the work here. Check the answers. I'll go ahead and highlight them really quick. See if you got the same solutions to your quadratics that I did. Okay, I do want to look at 3 more problems with you guys. So if you go to questions 8, 10, and 12, go ahead and try 8, 10, and 12 very quick. And then unpause when you have finished those. All right, for question 8, this is a slip and slide problem. So I went ahead and I slid 4 back, and I got x squared plus 12x plus 36. And then I had to find my factors of 36 that combined to 12, and I got 6 and 6. So I have x plus 6, x plus 6, and then I had to slide that 4 back under. So that's what I did here. I reduced. 6 over 4 reduces to 3 over 2. And then I had to move that denominator 2 over. So you'll notice both factors are the same. 2x plus 3, 2x plus 3. Since these factors are the same, I only need to solve for one of them. So I ended up getting negative 3 over 2 as my one solution. So if I were to graph this, I would have my vertex on my x-axis. I would have one solution right here. And it would look something like this. Not perfect, but kind of like that. Question 10, we had to make sure these equaled 0. So far, all of our problems already equaled 0, so we didn't have to worry about that. These last 4, 9, 10, 11, and 12, do not start out equaling 0. So I had to subtract 10x on both sides. And then I had to rewrite my problem, and then I did my slip and slide. I found factors of 24 that added to negative 10. These are negative 6 and negative 4. Once I had those factors written out, I had to slide the 8 back under, and then I reduced 6 over 8 to 3 over 4, and 4 over 8 to 1 over 2. Both denominators I had to move back up, so I got 4x minus 3 and 2x minus 1 as my factors. And then I solved for h, getting 3 over 4 and 1/2 as my two solutions that I wrote in my nice little curvy brackets. And then question 12, we will do really quick together. We have to make sure one side equals 0 to start. So I'm going to subtract x squared and 2 on both sides. X squared has a like term, the 2 does not. So when I write this out, I will end up with 4x squared, and then bring everything else down, plus 7x minus 2 equals 0. I then have to slip and slide, so I slip the 4 back. I get 4x squared plus 7x minus 8 equals 0. I find factors of 8 that will subtract to positive 7. So I have 8 and 1. The 1 is negative. I go ahead and I write these as factors. X plus 8, x minus 1 equals 0. It is a slip and slide, so I have to slide the 4 back under each of these. 8 over 4 reduces to just 2. 1 over 4 does not reduce, so it must go to the front. We have 4x minus 1 equals 0. These are our factors where we would have stopped last chapter. But now we have to finish solving. So we kind of split these down the middle. We set each of them equal to 0. And we solve for x. So x equals negative 2. And x equals 1 over 4. So my two solutions, if I were to graph, are negative 2 and 1 over 4. If you would like to write down the rest of the problems, that is a-okay. You can go to Google Classroom and find the key that goes along with this. Otherwise, have a great day.